Hello, everybody. Welcome to our webcast here, our webinar. We're going to be talking today with one of our customers, one of Duncan Parnell's customers that has recently installed their first Trimble monitoring system. And it's the goal is to really highlight some of the challenges, best practices, things like that, that this customer, Draper Aden and Associates, has learned during the course of implementing the system. My name is Joe Priesner. I'm with Duncan Parnell. I manage the technology group here that's focused on some of these technologies, some of these products that require a little more support and knowledge. And we help our customers get up to speed with this stuff as quickly as possible. I've been with Duncan Parnell now for about 10 months, but prior to that, I was in consulting, doing monitoring projects, large-scale monitoring projects since about 2009. I'm joined today by Roland and Cheryl. Roland's from Trimble, and then Cheryl is from Draper Aden Associates. He was the one responsible for setting this up. So I'll let them introduce themselves.
Perfect. Hey everybody, my name is Roland Chen. I'm the monitoring sales manager for the Americas, or one of two of them. So I'll be here to just kind of walk us through a little bit of the Trimble portfolio, so that way we can all be speaking the same language and just answer questions as they come up.
And Cheryl.
I'm Cheryl Stockton, survey team leader for Draper Aden Associates here in Charlottesville. Had been working with Skanska on a couple other projects, one at James Madison University, and more recently one at UVA hospital expansion. It's a multi-story addition to the hospital here in Charlottesville, and it's the largest construction project that the university has ever done. And as that project was wrapping up, Skanska was awarded the Alderman Library expansion project and got us on board to do the survey construction stakeout. And then a couple of months later, Skanska asked us if we'd be interested in doing the monitoring as well. And we said we were definitely interested in it, but it was clear that we didn't have all the expertise to do it. So we asked Rich Lindenberg with Jenny Elsner to team with us. He's a structural engineer. And Rich was also, he was actually the one who suggested that we use ATSs for this. It wasn't in the project specs, but he came up with a plan, and we presented that to Skanska and to UVA, and they liked it, and they awarded the monitoring program to us.
That's cool.
Yeah.
Now the format for today is we're testing this out, trying it out for the first time here. Is we're going to first talk about, Roland's going to talk about the Trimble monitoring ecosphere for about 10 minutes, just give you an overview of all the products and kind of how they go together. And then Cheryl's going to talk a little bit about the project. We'll show some images from the project, just a few slides of the setup and what the project looks like. And then we're just going to do a roundtable discussion between the three of us. I think Riley might chip in. Riley from Trimble's on, he's online too. And then we're just going to talk about some of the challenges and things like that. And feel free, anybody that has any questions, you can enter a question there. We have somebody monitoring. Marissa, one of our marketing specialists, is monitoring the questions, so she will chime those in as we're going. So Roland, why don't you take it away and show us the Trimble monitoring portfolio?
Yeah, for sure. So we'll just start and go over, again, all of the offerings that we have and kind of different technology and software solutions that we have, so you guys know what we're talking about. Otherwise, when we're talking about total stations and software and stuff during the roundtable and things like that, it might be a little confusing. So to get everybody on the same page, we'll just start there. Trimble monitoring is really all about automated movement detection with confidence. And so it's about more than just taking data in the field and delivering it to whoever needs it. It's really about taking the data and making it useful so that you can make those informed decisions about your site. Because it's one thing to have an Excel sheet with displacements and numbers and stuff on there. It's a totally different thing to get those automated alarms and those in-depth charting and analysis options and reports and everything like that. So it's really designed to make it easier to manage a site that's got things in motion and complicated movement going on. Trimble monitoring as a whole has been around for more than 20 years. We've done thousands of installations across the globe, ranging from just a few sensors with a single total station and prisms, up to a few thousand sensors with total station and GNSS and geotech and everything integrated in there. On the same lines, we have sites that run for anywhere from a few months to 15 plus years. So the system is really supposed to be as deployable and kind of customizable as you need it to be. We also have hundreds of distribution partners across the country serving our customers, doing local support, service, as Joe said, a lot of different consulting work, and being that if you need it, a local resource for all the knowledge and things that you would need. We offer everything from that semi-automated to that fully automated system. So as we like to say, from the tripod to the pillar installation. So the semi-automated being focused on that traditional manual workflow, but really just automating those workflows. So if somebody's going to site with a total station or a GNSS rover or geotech equipment, and they're taking those measurements manually, we're really working to make it easier to do that so it frees somebody up on site to go do other things. So with the total station and data collector, it's got a module on there that will run and run the rounds for you. So you can set your total station up, collect your data collector, run rounds, all day long, and then tear your stuff down, go home, come back 2 weeks later, set it up and do the same thing. And then we also have that fully automated setup. So when you set your total station up in the field permanently to run 24/7, either because you have a higher risk structure that needs higher frequency data on it, or if you're operating for a long time, it just makes more sense to set it up permanently so you don't have to keep going back to the field. We really have a solution kind of dedicated to each of those workflows. Today we're focused most on automated monitoring, so we'll do kind of that highlight for the portfolio. There are really 3 main components to an automated system. One, obviously, is your sensors in the field. And with the automated system, there's a lot more flexibility with the actual sensors that you're using. So you can use anything from the standard total station and prisms, GNSS systems, and adding geotech and weather stations to that mix. So really combining all sorts of different data types. Everything in the field is going to need power and communications. Anybody who's set up a system knows that that's a key component. And then along with that, we have the software package called Trimble 4D Control, or T4D. And that's split into 2 sections. So there's T4D Control Server, which runs as the backend that does all the data collection and data processing. And then the front end, which is called T4D Web or Trimble 4D Web. That's really it's what users and customers are going to interact with. It's the tool we have for visualization and reporting and alarming. Really anything that's going to be that data visualization. For sensors, I'm going to go through that quickly. We use the Trimble S series for the total station. The S series comes in all sorts of different flavors. The workhorse is the S7. That's going to be kind of the all-inclusive total station. It's going to be available in robotic and auto lock flavors. So if you're going to do some robotic surveying, you can use it and deploy it in multiple places. It's really good for general surveying. It's also really good for monitoring. It's just kind of the standard deployment for total station. We also have available the S9, which is specable with a lot more options. So it's really similar to the S7, but you can get it in higher accuracy EDM and higher accuracy angular specs. And you can also get it with long range find lock. So if you have some more specialty applications that require higher accuracy or longer range, you're going to want to go with something like the S9. And then we also have the S5 TIM, which is the scaled back version that's totally dedicated to monitoring. We don't deploy these as often, but it is available. So if you need it, you can get something dedicated to monitoring. You're going to set up maybe in a rough environment that's going to run for a bunch of years and you're not planning to deploy it anywhere else. The S5 is a good option for that. The total stations are extremely reliable and durable. And so they are IP65 rated and use a frictionless magnetic drive system. So they're super impervious to things like moisture and dust. And so it just lets you set it up in the field and know that it's going to keep running, and it's totally designed to be out there 24/7. You don't have to worry about, if it rains, you're going to have to get a new total station or something like that. It's really designed to give you that confidence you need to install it and run it all the time. They're also super interchangeable. So if you have, maybe your total station needs to be calibrated because it's been out there for a bunch of years, you're more than free to take it off of the tribe rack and then put a different total station back on and just do a hot swap and keep running. Get the other instrument repaired or calibrated, and then put it back out in the field. The S series is also our standard survey total station, so it's really easy to deploy a total station from if you're a surveyor and you have a few at your hands, you can take one out of your fleet, put it in the field and have it run for a bunch of years, and then take it off and put it back in your fleet and use it for surveying applications. Most total stations are also specable with Trimble Vision, so you can have a camera in your total station that just makes it a lot easier to manage your site. You can do things like add targets remotely or just check the status of the site without having to go there. Monitoring sites can a lot of times be a few hours away from your office or where you live. And so if you're doing something simple like adding targets, it can save you a whole day's of travel just to get out there. So you just open the instrument, add the targets, it takes 10 minutes, and you close it and go about your day. So instead of having to drive that 3 hours on site and 3 hours back, you can just do it during your lunch break. It's also got fine lock and auto lock technology, which is really good for target separation. So if you're doing like a rail or a road or a bridge or a tunnel or even a tight construction site where there's a lot of prisms and they're spaced close together, having that fine lock can be a key feature for the total station. We also have GNSS offerings. As you guys know, Trimble makes a lot of GNSS. We have everything from survey rovers to base stations and everything in between. GNSS monitoring is great for either high interval monitoring, where you need to take data, at 20 hertz instead of every few minutes. So collecting data from a GNSS receiver is a great way to do that. It's also good for widespread settlement and regional monitoring. So a total station, has a range of, 1,000 meters, 2,000 meters. But a GNSS antenna can cover an area of a city or a state or a county or something huge. T4D is also really good at GNSS processing. And so having that GNSS in there and doing a combination of real-time and post-processing to get those rapid alerts and those high accuracy results, it's all super customizable and really easy to set up. It's also super flexible, and so you can use your base stations or your monitoring stations as one or the other. So if you have surveyors on site, they can connect with their rovers and do RTK or VRS corrections from the receivers directly. And then you have a multi-purpose receiver all of a sudden. It's not just dedicated to monitoring, and it's not just dedicated to being a site-based station, but you can use it for both applications. We also have all the accessories that you would need to turn your total station or GNSS or geotech equipment into a fully automated system. So things like prisms and houses and mounts and things like that. We're really a one-stop shop for everything you would need for monitoring. We have all different flavors of prisms. So depending on your needs, if you're doing your standard job where you just want to set up, 50 prisms all in L brackets, we have those. Your long-range prisms, your integrated GNSS, and your specialty prisms, pretty much everything is available. The mounted enclosures as well. And so we have high security or high protection options for your total station mounts. We can do wall mounts and pillar mounts. So any installation you have, we can work with it. As well as cabinets either for the setup M1, which is the field controller that we use for the total stations. And one that is large enough to house both the M1 and your GNSS installation. So if you have both on a site, you can put both in the same housing and just simplify the power and housing solution that way. In addition to kind of that standard geospatial portfolio, we have now geotechnical sensors. Now I won't go into too much detail on here because the world of geotech is deep and immersive, and we could spend hours talking about that on its own. But basically how it works is we have geotechnical sensors, whether they're going to be data loggers that are connected to something like a piezometer or a vibrating wire sensor, an extensometer, crack meter, or something like that. They'll take data automatically from those sensors and send it via long-range radio to the gateway. In addition, we have laser distance meters and tilt meters that can measure convergence and tilt on structures. All the sensors communicate with long-range radio back to the gateway. So the deployment is extremely flexible. We can have your gateway up to 15 kilometers away from your sensors. So you can have this at like a site office or an office down the street from your actual construction site or monitoring site, and everything's going to communicate and come in no problem. Transfers the data via API into T4D Web. And so you get all the standard features of T4D Web with your data visualization, reporting, and alarming, with your geotech sensors, and if you're using it with all your sensors in one place, so your total station, your GNSS, and your geotech. T4D is the software that kind of brings everything together. So it's really meant to make managing the site that much easier. There's a lot of different visualization tools and reporting tools that you can use in there. So whether you're doing a simple chart or you're doing a heat map, or or a scatter plot or anything like that. It's really made to give you the tools that you need to show the site, the health and the status of your site. So it's really easy to use a sensor management and data integration portfolio. There's a really powerful backend that does the geodetic processing and adjustments for your total station and GNSS. And there's all the visualization and reporting tools. So it makes it really easy to come in and see exactly where displacements are at if you're using the heat map. You can make charts and visualization tools that combine multiple data sets. So if you have your geotech or your GNSS in combination with your total station, you can pull all that data in one place and show it as one coherent data set. There's also the conditional alarming and reporting. So the same idea being you have a way to kind of cross-validate data. And so if you're doing, for example, a rail project and you have a combination of tilt meters on the ties and prisms on the rails itself, you can have charts and reports and alarms that show that data in combination. And so you can also have a self-validating alarm that has to check, the tilt has moved this much and the prism has moved this much. And so now the alarm is real and it triggers and alerts everybody on site. So it's really designed to be as simple or as in-depth as you need it to be, depending on your project requirements. T4D, one of the most powerful aspects of it now is that it can integrate all 3 data types. And so whether you're doing a project with just total station or a project with just geotech, or if you're doing one with a combination of all different three different data types, you can bring it all together and use them kind of as needed. Perfect. And that is my overview. Do we have any questions come in? It's hopefully pretty straightforward.
So far, no questions. Just a reminder to everyone, if you do want to ask Joe, Roland, or Cheryl questions, use the questions pane in the GoToWebinar panel, and you can type it in there, and they will answer them as we go.
Perfect.
Perfect. All right.
I'll hand it over to you, Joe.
Yeah, thanks. Thanks, Roland. Why don't you go ahead, let's see, let me share my screen now. And you see my presentation yet?
Yep.
Okay, perfect. All right, Cheryl, why don't you take it away and we'll talk about the project, what it actually was, what you were doing out there.
Sure. The Alderman Library was first constructed in the 1930s, and the shape of the project is like a horseshoe. And there was a later addition in 1970, and that addition filled in that horseshoe area, and that's where they stored the stacks and the books there. And the architecture wasn't really the best place to store those books, and it also wasn't consistent with the original design. The original design in the 1930s with the arched windows and the columns, a really beautiful structure, and the addition just wasn't in keeping with that. So what the university wanted to do was basically make better use of that space. And so now they're building a state-of-the-art library addition where the old stacks were. And so part of the challenge of that is that we have to tie to the existing structure, and the courtyard is a very sensitive area of that structure. And the wings have total stations installed in all of those. What you're seeing here is basically the building is has been demolished or partially demolished, and you're seeing the wing over there on one side. And so they've done demo and are also underpinning all the new foundations for the building. So the new structure is going where the old structure was, and also being expanded and making a larger footprint of the library.
Yeah. And this is what the mount looks like. We've got 2 instruments out there. one on this mount here, and there's one directly across from it. I think the decision to mount the instrument on the building was just driven by all the points that we had to see and trying to get sight lines to them while they were actually building the foundation and building the foundation of the new addition here, a new part of the building. I like how they wrote "Do not lean" on this thing, on the mount there.
It's important.
Resting against it. But it was actually, both of these are very stable. They worked out really well.
Was there any monitoring done during that demolition? During that, just because structures in the way, but was there anything else
There
done?
was not.
Was there anything else done?
The original plan was to have everything installed before there was any demo whatsoever, but that isn't how the project progressed.
Right.
So like a lot of construction projects, that
Right.
it's a changing environment. You don't really know what's happening until it's there. So in some ways it wasn't ideal because we didn't have any baseline measurements going into this. And so after the demo was done, that's when we started installation of these targets, and Skanska actually installed the majority of the sensors on site.
That's right. So Skanska put most of the prisms up, and
Yes, they did.
I just put this image in here just because it's typical construction site. We're working on one instrument, and all of a sudden they cut this hole in the plastic and start flying steel in like 3 feet from other instruments. Oh my God. Just typical. So that's really the project and the images I had. So now
Of feedback on your side, I think there'll be an echo or something.
yeah, is that on Cheryl's side? I'm not sure. Can you guys hear me okay?
Yeah, okay, I can hear you now.
Okay. So that's all the images I had of the project just to show. And I can stop sharing my screen if I could figure that out.
That's the biggest.
There we go. So the rest is really just a kind of interview and talking with Cheryl and just discussing our combined experience. Now, Cheryl, you said you were brought into this project just because you guys were out there, you had a relationship with Skanska, you were already on site surveying, and then you brought in a partner to help with some of the other geotechnical type instruments, settlement and vibration, I think. Was there a monitoring, were you given a monitoring plan? Kind of describing where the instruments should go or the prism should go and things like that, or did you guys have to develop that on the fly?
Cheryl, you're muted now if you're trying to talk. Cheryl, you're muted now if you're trying to talk.
Unmuted.
Yeah, the specs did not call for ATSs to be used on this, and our teaming partner, Rich Lindenberg with WJE, is the one who recommended that.
Mhm.
He just felt that the absolute values of the ATS gave you better results and were more easily interpreted. So Rich did a lot of the planning for this, but I found myself in a position where I was also having to prepare project specs. Basically, how is the contractor supposed to install a survey monument? How are the stations going to be constructed for the prisms, the fixed prisms, and how are the targets going to be installed and where are they going to be installed? Rich had a plan of kind of a 2D plan of where they're installed, and we had to draft a 3D version of, where is that going to be actually in space, and use the project plans. So the when it was all said and done, I think that we had like over 100 pages of specifications that we had to prepare for this project, and that's the first time I'd ever done anything like that. So that was a daunting task.
Now, did they provide a schedule, like sequencing or anything to you to help you plan sight lines and your instrument position or anything? Or how did you come up with those instrument locations?
I worked with Rich to come up with a plan for the instrument locations. So that was something that we developed ourselves. The design team basically just waited for us to submit things, and they offered us very little feedback. Just yes, you can do this, or no, you can't.
Mm-hmm.
One of the things that kind of took us off guard was that they said that all the sensors, or almost all the sensors, would have to be attached to steel. So Rich had to come up with a plan for, not just screwing the prisms into mortar, but how to tap into the steel and attach them to a steel rod. So that was a little bit of a challenge, and also we had to show, what we were going to do after construction and removing of them and grouting the holes and that kind of thing. So lots of details were needed.
For sure.
And I'm always happy to see redundant sensor systems on a project. I think it's very critical. It's hard to make any kind of decisions as far as shutting down a site or stopping work if you don't have corroborating evidence. So I always highly recommend that. On this site, were you able to compare the data that you were getting from the AMTS to what you were seeing on the settlement sensors, or were you kind of combining it or looking at that data together?
Yeah, our teaming partner WJE is responsible for the reporting. Of course, we're involved in the day-to-day checking of the data and helping to explain what's happening with the data. And Rich is comparing that to settlement monitors and vibration monitors. And in addition, we're also doing periodic monitoring to make sure that other parts of the building aren't moving either. So we're checking that every 2 weeks.
Yeah, that's a good point, Cheryl. You guys are out there, you've got the 2 total stations measuring, I don't know, 40 or so prisms inside the horseshoe, but then you have prisms mounted on the outside of the building, outside the horseshoe, that you are monitoring just manually, and you're importing that data and displaying it right on the same map. So, and you can see the graphs and stuff like that. You can analyze it right along with the data that's automatically collected. I thought that was a good application. We can move on to the logistics installation. When you guys were installing it, you guys had contractor support, right? They built the instrument mounts and things like that for you.
Yes, they did a lot of the installation of the total stations, the wooden platforms that you saw, and also they poured some concrete pillars for some of our periodic data is also being monitored from something that could be used as a ATS. So we chose some locations that were strategically placed. So it's like if we start to have a problem in part of the building, we could switch an ATS to one of those locations.
Mm-hmm.
We did install the survey control, much of the survey control ourselves though, and installing on the side of the building did require a boom lift. And luckily we have somebody on our team that's boom lift trained, so that's helpful.
Yeah, that is super handy on these types of projects. Often the instruments in a location that's difficult to get to, and the targets are as well. So it's handy. And then having the right tools, going out there, having a rotary hammer, things like that to drill into concrete masonry. I find those are indispensable. And just you never know what kind of tools you're going to need. I always, whenever we do an install, whenever we're supporting a customer, I try to bring every tool I have in my toolbox, just in case. As far as permissions, we were talking yesterday, you said you had you had to go through some hoops just to get permission to install some of these targets.
Yeah, even though it's all on university property, there's a lot of different people at UVA that have to weigh in and agree on anything. So very much like our specs, we had to submit exactly where they were going to be and how they were going to be installed. One had to show details of things like that, and that had to be approved by a panel at UVA.
Yeah, and then more the other things on site that you need to worry about when you're monitoring. Roland mentioned during his presentation, communications and power supply. Mm-hmm. Out there at the Alderman Library, the same challenges. The power supply, it's nice. They did a nice job. Electrician came in, set an outlet right there. But how many times have you had to make calls, Cheryl, to have the power restored to the instrument?
This morning was the last time. So, yeah, pretty constant. It's gotten a little bit better. I know that the beginning of every day, Skanska has a little safety talk, and I know they regularly mention, don't touch Draper Aden's power source. And but people see that oh, here's something, I'll just unplug this. What's it doing anyway? So that happens more often than we like, but Skanska's great at stepping in and helping us out on a very regular basis with that.
Yeah, I've had many issues. I was working on a project out in San Francisco where one of our instruments was plugged into a site trailer right next to the refrigerator was also plugged into the same outlet, and the refrigerator kept tripping the breaker on the outlet, so our instrument kept cutting off. So there was a constant battle, and they got so fed up with the battle that they just unplugged our instrument permanently. So it's silly.
Between the fridge and the total station.
Yeah, we had another one plugged into. It was on the roof of a building that was a nightclub, so we can only get there starting at about 6 p.m. Get into there to do it. So if we had any issues with that instrument, we would have to go there when the bouncer showed up to open the door and get up on the roof and fix it in the middle of the night. Yeah. Same with communication. Now, a lot of our instruments are set up with a SIM card in the set top, just running cellular. But on this job, Skanska decided to go with their site-wide Wi-Fi. And we set it up, and it's kind of a similar, correct me if I'm wrong, Cheryl, similar situation with the power. Their access points spread out throughout the building are also plugged into nice, convenient outlets, and they keep getting unplugged about at the same rate as the instrument itself. About at the same rate.
I'm going to charge the phone, right?
So
yeah, they sometimes get unplugged, or just the Wi-Fi might go out for one reason or another. So again, my partners at Skanska, Dan Swain and Lisa Witt, are really good and responsive. I'll send them a text on a regular basis and they'll check into that for me. And if it's a little more complicated than that, then, we'll send the Draper Aden person over to investigate further. And, we often reach out to Joe. Hey, Joe, we've done what we can do. Help figure this out, please.
Yeah, I get online, I get on their server, get on their set tops remotely and try to figure out what's not working.
Yeah.
We also are using PepWave device connectors out there on that project to tie the little set top M1, the controller for the instrument, into the on-site Wi-Fi.
Mm-hmm.
And they have a great remote interface, so remote management application or platform. So like today, when I saw one of Draper Aden's instruments was down, I could get into that management console and see and tell Cheryl that, yeah, it's the West instrument seems like it's offline. So I just need to check power over there, check communication.
Hey, Joe, I'm just going to pause here for a couple of questions real quick.
Shoot.
So earlier we had one come in where David Perez was asking if you can get raw data basically from the instruments, get calculated coordinates and different things out of there. So not just those charts. And the answer is yes, you can get basically anything you need out of it. So if you wanted to get just adjusted coordinates in a CSV sheet, you can set up a report to just push that data via FTP, or you can get an email report with Excel sheets and stuff in there. He also asked if the total station can track reflectorless targets, so not just prisms. And the answer is yes and no. So for automated systems, because it's not somebody turning to the same target every time and eyeing in through the eyepiece like what they're aiming at, the reflectorless monitoring is a little bit limited. So you really end up getting only a one-dimensional change, so only a change in the EDM distance that you're monitoring, because it's never going to be self-centering. But you can use it for supplemental data. So we don't like to do purely reflectorless projects. But if you have something like this set up and you wanted to also turn to a spot on the wall and just measure and make sure you're not getting inward or outward settlement, you could do something like that too.
Yeah, two other comments on that. On this project specifically, Draper Aden's partner, WJE, wanted to get the raw coordinates. Mm-hmm. So the raw coordinates are being raw adjusted coordinates are being spit out of T4D, Trimble 4D control, mm-hmm. To a file, and then T4D automatically sends that to WJE's FTP site.
Perfect.
So that way their engineer could do their own graphs and do their own analysis. What was the other comment or other question?
Reflectorless. Cheryl, do you have reflectorless targets on here? So DR measurements or anything like that? Or is it all through Prism data?
Yeah, this is all Prism data.
Okay.
Yeah, it's all Prism data. We are working on testing for a project up in Toronto for reflectorless pavement measurement. We're doing some testing here and we've got a demo site on the roof. And we've got a customer that is interested in the specifications on that project. It's a tunneling project in Toronto, require reflectorless pavement measurements out in the street. So we're testing it here with our instrument on the roof, just to give them some comfortability that that's going to work. Now, mm-hmm. like Roland says, it's always going to turn to the same angle and just shoot the distance. So if a car is in the way, we can set a breakout limit that if the elevation changes a certain amount or the horizontal distance changes a certain amount, it will ignore that measurement. So you just have to be, just use some reasonable numbers for that. So it's working pretty well. The vertical we're seeing on pavement, that's about 200 to 300 feet away, is probably 2 to 3 millimeters. So we're getting pretty good results on that.
Perfect.
Let's see. So communication. The other thing is control. Wanted to talk about that a little bit. One thing I preach is keep things simple. If you can keep it as simple as possible, you have a fixed instrument location, you have a fixed backside, and you monitor. You just turn and monitor. That's probably going to be your most stable, most reliable type setup. However, that's not always possible. Often you have to install the instrument inside the zone of influence like we are here on this project, which then complicates things. This project was further complicated by the limited sight lines of both instruments. They're turned into the horseshoe, and they can only see about maybe 50 degrees outside that building. So we really need to get creative with the control in this setup to basically tie both instruments together, use some common control points that were still inside the zone of influence. So they're allowed to move in the adjustment, but they're used basically to tie the two instruments together. And then both instruments could see about 3 to 4 control points, probably 4 to 5 control points outside the zone of influence. So we use the two common control points to tie them together, and then use those basically 9 or 10 control points that were on the ground outside the zone of influence to fix it to the site. Now that does cause issues if you lose control points. If like today, enough control points, one instrument was offline, one instrument had some of its control points blocked, so it wasn't even couldn't figure out where it was, basically.
Right. And that's the of shooting the dynamic environment. Like you always need to fix control somehow to make the adjustment.
Yep. And Skanska was good to work with. We told them we needed some extra points set. So we just they actually reinstalled it, just pulled out a pillar from one location, and they were kind enough to dig a hole and throw it in another location.
Perfect.
So we set up a prism on that. But that's really the common point. That's really the rule of thumb is try to keep it as simple as possible. The other thing is if you, a lot of monitoring consultants, if they're just monitoring, they're not surveyors, they don't understand how to put a site on the ground and tie it into the site control. I have to give Draper Aden props on this. It was probably the best control I ever got on any project. It just worked. And that's not often the case. So the other thing, Cheryl, the other thing we were doing on this project is because we have all this control and it's a complicated adjustment, we are also measuring our checkpoints. So we basically learn the control points as monitored points. So after the adjustment's done, we kind of have real-time residuals based on a secondary measurement on that is unconstrained. How did you use that, Cheryl? How did you use that information to help with your customer or your client?
Well, we get a lot of questions about, hey, it looks like the data has spiked here, and things that I would normally ignore as a conventional surveyor is like 50%. But they would say, well, but everything's moved 50%. So why is that? And so I'll come back and say, oh, well, some of our survey control points were blocked. So it uses those survey control points to resection, figure out its position, which is great because the ATS can get bumped. It could move a hair one way or another. But that really wasn't enough to answer their questions. So they'd say, well, how do we know that that's how it affected this? So what we can do is we can just do an easy graph and say, okay, this point, our survey control point, which is outside the zone of influence, moved 100 to the east. And this other control point also moved 100 to the east. And you're asking about these other points here that, your question is, why are all the points moving 100 to the east? It's like, well, so our survey control points as a check, we know they haven't moved and they correlate exactly with the number that you're looking for. So that's a real easy visual that anyone can understand and doesn't take a lot of time to analyze it.
Do you mind if we take a look at that graph, Cheryl? I know we saw it the other day. It looks pretty nice.
Now you're putting me on the spot, Ron.
Yes.
I gotta find it. I think I have it somewhere. Let's see.
Yeah, I realized the one I sent was actually an elevation change, but yeah.
I'll just go to the website. That's a good.
Oh, perfect. Yeah. Maybe just show up for a second.
Website.
Yeah. See some data.
Yeah, go ahead. Let me share my screen, Riley.
Perfect.
Let's see.
You should be able to, Joe, if you go under the sharing tab, there should still be an option to choose one of your screens to share.
Oh, okay. Let's see.
Kick it off.
Let's see.
Oh, sweet.
Is that it?
We can see T40.
So this is basically a live view. You can see, let's see, let me refresh. These might turn not red anymore, turn green or other colors. Hey, that was the instrument that was off. It was covering this whole side of the building. So under one of the analyses here, set up for Cheryl, was a graph. Control check.
Oh man, you guys get pretty in depth with the analysis, huh?
Oh, they got that. Yeah. They were Draper Aden's, the Jess was the one that did a lot of these graphs. I showed her, trained her on a few, and she went bananas and did all the rest. She did a really good job. So this is just you can see different control point. These are checkpoints on it. So checking 806 from one instrument. And then this should be temperature. Yeah.
Mm-hmm.
So that brings up another good point. We always graph temperature over any structural monitoring analysis just to show the correlation between temperature and your building movement, because that is that's probably the predominant driver of movement in the structure is temperature.
Yeah, that's pretty standard across all projects. We see that everywhere, where the biggest thing you're seeing is that diurnal effect from things just expanding and contracting throughout the day. And so if you only set it up the first week, people are always like, why is it moving 2 millimeters, from noon to 3? It's like, well, this is getting hotter.
Exactly. Now, all these measurements are compensated for temperature and pressure.
Mm-hmm.
The instrument itself has a pressure transducer in it.
Yep.
The temperature probe is actually part of the set-top controller, and it's a separate probe because the temperature inside the instrument is always elevated over ambient. So there's a probe that we usually stick outside the bottom of the enclosure that logs temperature, and all those values are brought in and used to compensate every single measurement. It's actually logged, the temperature and pressure are logged on every line inside the raw GKA file. So this is just a graph that shows you see some at this point here, the control was getting mixed. There was issues with the control, and we had 300ths. Now we can set tolerances inside T4D to, if the adjustment doesn't work, we can just reject it. So if we exceed certain limits on your quality of the adjustment, we can just reject it. We can send warnings, alarms, and also just reject it. But this is one of the graphs that on the control point checkpoints that was used in a horizontal and a vertical one.
Joe, would you mind showing that custom view one more time too? That view of the horseshoe with the targets there?
Sure.
I know there's a good anecdote about some of the displacements on there.
Oh, yeah. Yeah, this one, actually I have to click on it. So this column right here was the problem child in the beginning. They started working on this foundation. They're underpinning all this. So they're working on this foundation, and this column started to move. And it was right in the very beginning of the project. And so everybody was questioning, is that really movement, blah, blah, blah. But we could show them that, the other ones weren't moving. We got 2000s here. All these other columns weren't moving. And so it was very early in the project. And you could see this graph, you could see the trend. The trend was evident. It was moving, about half a hundredth a day. And it was also with settlement as well. So it was not only kicking out into the excavation, but it was settling. So you could see what was happening, and they finally caught it. They finally stabilized it, and but this was the one that was causing the consternation over a 32nd of an inch, because it was a 32nd of an inch underneath the threshold to shut the job down. So bouncing back and forth.
Yep.
And so that's why it became all of a sudden a critical issue. The superintendent backed into one of the control points and knocked it just enough to change the whole adjustment by a 32nd of an inch. And it became my job to chase that down and try to figure out what it was, relearn that point in its new location, and fix get it back to where it was. And, you know, we're talking about a jump of a 32nd of an inch on a graph.
Yeah, it can be critical sometimes.
And you can also see this are some of the manual monitoring points that Draper Aden has started incorporating into the graph. So this is a good visual of how you can incorporate manual monitoring points along with your automated points. All the ones that
you have somebody going with their total station and setting up independently, right? And then shooting them and uploading them into T4D.
Yeah, that's a question for Cheryl. I think she said once a week, right?
It's actually supposed to be every 2 weeks. Had an issue with our data collector, so we're a little bit overdue, but we're out there monitoring right now, actually. So, but yeah, basically every 2 weeks.
Yeah, so they just take those coordinates, adjust the coordinates, then import them, make sure they have the right IDs, and then import them right here in the website. And it updates all the graphs. They can get all the same kind of graphs on these that they do on the automated points. He's got changes, dude. See how long you've been doing this one. Yeah.
Oh, sweet, yeah. Yeah. So same type of graphs. But you can see, these graphs are all editable. You can turn things on and off. The analyses are where you have regressions and things like that you can do to spot trends. Okay, we're getting close on time. Let's see. Yeah, I think we just had one more question come in, which is kind of to do with the accounting and project management. And so this is a web page. You can publish it to a public URL. And because it's accessible via the internet, we want everything to be kind of locked behind some security. So anybody that has access to the system gets set up with an account that is bespoke to them. It's their email address with a custom password. You can also set all sorts of different access levels there. And so a lot of people are just going to have kind of read-only access to this, where they just come in and see the charts and receive reports. And then you can have some key people be analysts or admins on the project. And you can also have multiple project sites run through a single instance of T4D. So if Scansco is running this Alderman site and another site at UVA, you could split it into 2 places. And then just people working on one side or the other can receive reports and emails that are, you know, only relevant to them. So not seeing multiple data sets they don't care about. So things can be very customizable that way.
Yeah. And there is an IT component to this. So if you're going to tackle an automated monitoring project, you're going to be installing. You probably want to dedicate a server to it. You're going to be running Microsoft SQL Server. We typically, most of our customers are now running it in Azure. Microsoft Azure is fully Azure compatible. This one, Draper Aden's IT department is very good, very proactive, very responsive. They're the one, most customers they'll let me get into their server and kind of have a user ID and log in. Draper Aden is very security conscious for a good reason. And so all I do is I send them a go to assist link, and I haven't waited more than 5 minutes to get into their server to troubleshoot something. So their IT department is great, but you may have to involve if you have an IT department, involve them. We met with their IT department, did an online meeting probably a month before the project was scheduled to start, so that we could install the software, show them all the different items that they'd have to set up a security certificate, set up a dedicated email address to be able to send out your alerts and alarms and your invitations to join the project and have access to the project, so to receive your credentials. So you do have to deal with that. But that being said, we have another customer, you might even be on here, Bruce, I'm talking to you, that ran on a doorstop laptop on his credenza. So you don't need a whole ton of IT. You don't have to have a very sophisticated IT, but you do have to run those components.
For sure.
And we also, the other thing here at Duncan Parnell, we offer our customers data hosting. So if you don't want to be responsible for running that, or don't have the in-house technology, in-house capability to run a server, run something in the cloud, we can certainly do that for you. We just charge you a monthly fee to boot up all that infrastructure. We do it for you in Azure, and set up a completely separate Azure account and infrastructure dedicated to your project. So we've had the people taking advantage of that are usually the people that don't have any IT support, and the companies that have giant IT departments and are very security conscious. They don't want to have anything to do with running a web server inside their infrastructure.
Yeah.
So they fall into those two categories. So talk a little bit about websites and setting up the stuff, reporting and alarming. Last, operation and maintenance. Just because this is automated does not mean in any way that this is maintenance free. And you can see just by speaking about this project today that it does require maintenance. You have to go out and troubleshoot things. Sometimes something doesn't work. We had, again, I'm going to pick on Bruce Flora. His instrument kept losing orientation, and it's really just I kept telling him tribrac's moving. It was just his mount was just a little rough, and the tribrac was catching on a piece of gravel, and it was kind of top of concrete. So once we straightened that out, it was all good. But it takes maintenance. You got to go out there and clean prisms. You have to unblock prisms, move things that get in the way. And we're talking a lot today, mostly about total stations, because that's what we're running on this, what Draper Aden's running on this project. So there are other options the geotechnical sensors and GNSS that we're going to talk about today. But for total stations, they do require line of sight maintenance, cleaning the prisms and that type of thing.
Yeah.
Just troubleshooting communications and power and all that stuff.
Yeah, and any site has its own challenges. It's not to say it's anything impossible. It's just kind of the cost of doing business. Like, you always have to be aware of things that can change on site, and when they do, you just got to take action for it.
Yeah. The prisms, L-bar prisms make great coat hooks. When it gets cold, everybody's hanging their jacket on the prism. Is there anything else? I think that's all I really had. Cheryl, did you have anything else you wanted to add?
Oh, just one thing about the periodic monitoring is there's an app that you can use, which is really helpful. It allows you to collect the data much more quickly, and especially if you've got really steep angles like we have, and especially we'll have in courtyard monitoring. It would be really difficult to, even with an angled eyepiece, to see exactly what you're doing. You need to double those angles. So it's great for that application.
For sure. And you're talking about Trimble access monitoring?
Yeah.
Perfect. So yeah, just a little more info on that. Trimble access is the software package that we use for field data collection to the total station. and there's a monitoring module on there. So you measure your prisms one time, save it as a project, and the next time you go to the site to set up, you can just tell it, measure around, and it'll just turn to the prisms and measure them for you. So it can save you a bunch of time when you're on site, especially if it's hard to look through the total station.
So, all right, well, I think we're out of time. So I appreciate everybody that participated in this. Thank you, Cheryl. Thank you, Roland.
Yeah, thank you guys so much.
Yeah, and then everybody that watched it, hope you enjoyed it. Hope you got something out of it. But if you have any questions, feel free to reach out to me at Duncan Parnell. And I'll give a shout out to Trimble's monitoring support. Their support team that's dedicated to the monitoring products is fantastic. And again, probably less than an hour response time on any question. I don't want to set a standard that you can't meet, Roland, but that's my experience, really, honestly.
Yeah, we take a lot of pride in our support, so feel free to reach out anytime.
So yeah, if you need anything, give us a shout. So thanks for attending, and everybody have a great day.
Yeah, thanks everybody.